Our last topic for chemistry calculations will be density. And I think you'll find that you at least have some vague memories of density from some of your other classes. Now, the density of a substance is its mass over the volume. So it's mass divided by volume. Now, the units that we will typically use are grams per milliliter if we have a liquid. We'll use grams per centimeter cubed, typically, if we have a solid. Do you see parentheses L means liquid, parentheses S means solid, and we'll use grams per liter for gases because gases are not very dense. So when you put in parentheses like that, that's kind of some new symbols in chemistry. That's liquid, that's solid, and we use G for gas. Now, let's take a look at 225 for this. Now, density is an intensive property. We talked about intensive physical properties before. So an intensive physical property is independent of amount. So, and I think you think of this with water, because if I asked you what the density of water is, many of you could come up with the value 1 gram per milliliter. Now, that's the density of water if I have a, 64-ounce big gulp, and it's also the density of water if I'm dealing with just an 8-ounce glass of water. The density of water is independent of amount. And that's because this value has already been normalized on a per milliliter basis. So when we look at this question, we've got the density of a metal block, and they give it as 5 grams per milliliter. So what we did to this metal block that was 5 grams per milliliter is we cut it in half. So if I cut it into 2 equal, and frankly it doesn't matter if they're equal or unequal blocks, it's going to be the same. So the question says we're going to cut it into 2 equal blocks. Well, it's still going to have the same grams for every milliliter. So this density is 5.00 grams per milliliter, and that's 5.00 grams per milliliter. So what the question is really after here, in terms of seeing what you know, is that density is an intensive property and it's independent of the amount. So let's go on to our next question. You can list givens if you want, or you can learn to highlight givens. They give me a density of 19.3 grams per milliliter. It asks me what the volume is, or for centimeter cubed, I automatically said milliliter there, if I have 200 grams. What I like you to do is list your givens or circle them. I'm fine with circling. List your givens. You want to check your units. We have to have agreement. If density is in grams, our mass has to be in grams. Since our volume in the density is in centimeter cubed, that means that the unknown volume that we solve for is going to be centimeter cubed. Then you want to write down your formula. We're not using dimensional analysis anymore. We're plugging directly into a formula. So our density formula is that density is mass over volume. So they gave us 19.3 grams per ml. I've already checked my unit, so I'm not going to really worry about plugging units in at this point, over volume. Now, there's really 2 ways you can approach this in terms of solving for an unknown in a denominator. That's usually a troublesome algebra problem for young people. So I'll show you 2 approaches that we're going to use in this case. One is the more traditional approach. Since we're dividing by volume, the opposite operation is multiplication. So I'm going to multiply both sides by the volume. That gets that volume out of the denominator. Now, I need to get volume by itself here. And so I need to bring the 19.3 over. And since it's multiplied, the opposite operation is division. So volume would be equal to 200 divided by 19.3. And if we did that division, I'm going to get 10.4, and it has to be centimeters cubed because this was the volume reading in our original given. Now for sig figs, this has 3 sig figs, this number has 5 sig figs, and remember in multiplication and division you've got to go by the fewest number of sig figs. So that's why I put 3 sig figs in my final answer. Now there is an alternative way of doing this, and let's take a look at that. What you can do, and you can only do this, it's valid mathematics, but you can only do this if all you have is multiplication and or division. When your unknown is the denominator, you can invert both sides. So if I invert my left-hand side and invert my right-hand side, as long as I do the same thing to both sides, I maintain my equality. That gets my unknown out of the denominator. And now to get the 200 over to the other side, it's divided on this side. So I'm going to do the opposite operation and multiply to get it to the other side. I don't care which way that you do this. You just need to find a way that works best for your brain and make sure we try a few of these. Now, let's go on and do our next one. Our next problem gives us a lot of data. So let's see if we can kind of ferret out the data in this. We have a liquid, and the liquid fills the graduated cylinder to 45.8 milliliters. Okay. Now, then we weigh an empty graduated cylinder, and it weighs 26.5. Add the liquid in the cylinder is 70. I think in this case it'll be helpful to list. So our volume, and it's of our liquid, the volume of our liquid was 45.8 milliliters. Now they gave me my mass of my graduated cylinder, and that was equal to, the empty graduated cylinder was 26.5 grams. My mass of my graduated cylinder plus my unknown liquid was equal to 70 grams. In this case, I think that listing your givens right now will make it a little bit more evidence that I can find my mass of liquid, that my mass of liquid alone is equal to the mass of liquid plus the graduated cylinder minus the mass of the graduated cylinder. So this is my graduated cylinder plus liquid. This is my graduated cylinder. So that's going to give me my liquid alone, and my mass of my liquid is going to be 43.5. This is something common you would do in the lab, and we have a very good density exploration for you. Now, to calculate my density of this liquid, I have to take my mass, divide it by my volume. I've now calculated the mass of the liquid. You can't include the mass of the graduated cylinder here. We want the density of the liquid alone. So we have 43.5 grams divided by 45.8 milliliters. And that gives us a density of our unknown liquid as 0.950 grams for every milliliter measured. Notice I put 0 point. It makes that decimal point much clearer. All of my values had the 3 sig figs, so my final answer had 3 sig figs. Now, I have just a couple more concepts in density, so one more video, and believe it or not, you are done with videos for your first flipped experience.